relation between enthalpy of solution, lattice enthalpy and hydration enthalpy. If I take an ionic compound, let us take an example NaCl, which is a solid, added to the water. If this is added to a sample of water, now the energy released by completely dissolving the compound in excess of water is called enthalpy of solution. This is called as enthalpy of solution. The amount of energy released by dissolving completely 1 mole of a compound in excess of water, that is taken as enthalpy of solution. Same way, if you talk about lattice enthalpy, if NaCl is splitted into their respective gaseous ions, if 1 mole of NaCl is splitted into respective gaseous ions, the enthalpy, the energy released or absorbed in the process. For this process, energy is required. So the enthalpy which is required, which can be taken as positive, enthalpy required for the dissociation of 1 mole of ionic lattice into constituent gaseous ions is called enthalpy, lattice enthalpy. Hydration enthalpy, if you take, if you have a ion in the water, if there is a particular ion in the water, whether a positive ion or a negative ion, if this is surrounded completely by, if this is surrounded by the water molecules, if this ion is surrounded by the water molecules completely and stabilize this particular ion, the energy of stabilization of the ion by water molecules involving ion dipole interactions, that type of interactions leads to enthalpy of hydration. So the enthalpy of hydration is the stabilization energy of an ion. Now, having these three things, what is the relation between them? Let us see. If I have a compound XY which is dissociated into respective ions involving lattice energy and dissolved in the water aquated, that means every ion is being hydrated, then it is hydration enthalpy. Then you get hydrated aqueous ions or aqueous ions. Directly when you say the enthalpy of solution, this is a single step process, this is single step process, and this is your multi-step process. You get this is a multi-step process. Now according to Hessler, the total enthalpy should remain constant. Enthalpy of solution in single step is equals to enthalpy, lattice enthalpy plus hydration enthalpy. This is the relation between enthalpy of solution, lattice enthalpy and hydration enthalpy.